heat transfer area, surface area is one and the same, but in the plate heat exchanger there's actually two different area calculations. There is the heat transfer area used for heat transferring heat, then there's the total area on the plate. Now, the total area of the plate would be measuring the top to bottom, side to side. But your heat transfer area is actually inside where the gasket goes. So there are two different areas. And you can be careful how you specify in your data sheet. Some people we've noticed, especially on the refrigeration side of things, they say total area. They're measuring the total area of the plate, which is erroneous, because it's only the heat transfer area that you need to concentrate on. And on this plate, if I turn it around, the gasket goes here. The distance between the outside of the gasket to the end of the plate has actually been reduced compared to our previous models. Again, this is the T series, and in doing so we've actually increased the heat transfer area on that plate. Dimensionally it's exactly the same as the M series, but it has a higher heat transfer area. Now, excess area is a good topic to discuss. When we design an exchanger, we can design with zero fouling margin or excess area. It's kind of the same thing. It's a parameter that goes into calculating the heat transfer area. Now, if you have a pressure drop issue, in most cases, if you're designing, say, for 15 kPa, and you see a large excess area, that means the heat exchanger has had to increase the number of plates in parallel or channels to bring the pressure drop down. So the plate geometry is wrong for that design, so you add more plates in to bring the pressure drop down. So if you have low pressure drop, high excess area or fouling margin, that's what's happening in the background of the mathematics. Okay, so if you have the right geometry, and this is where Alfa Laval to some degree has a real benefit, in that on some of our medium to large heat exchangers we have 3 channel gaps, 2.5, 3 and 4. Now if you have low pressure drop, you want a larger gap. As you increase the gap, your turbulence decreases, your pressure drop decreases, but you pay for an increased area. But the larger the gap, the plate itself is less efficient. So you maintain, you control excess area because you've got a less efficient plate, but you can control pressure drop. And the design engineer has to kind of manipulate this. But having 3 channel gaps allows us more options on the design.